very feeling sleepy after lunch. So I promise this is not going to be a very technical session, so it's going to be a breeze after so many tech sessions today. So I'm talking about something which is, I guess, very unusual. People don't usually talk about things. People talk about a lot of technical things. So I'm talking about things we do for fun. I'm talking about recreational programming. So, so what is recreational programming? Before I start, let me give a brief of what I do. So my name is Anand. I've been doing programming for almost 2 decades now. I started learning programming in 1997 when I was in BE. And fortunately, I never did computer science. So all I learned programming was on my own. So there was no constraints. So I felt there's something very nice about that style of learning, and I don't find that happening very much these days. So I thought there is something that I can share for you. How many of you are actually early in your learning programming for new? How many people are new programmers? Yeah, it's quite many of you. Okay, so I'm sure like many of the talks must have went above your head. So. Sorry about this. Yeah. So let me talk about what recreational means. Okay, people talk about recreational things that you do for fun. Okay, things that you do for enjoyment, not when you're doing work. So people talk about recreational mathematics, but I have never heard people talking about recreational programming. So this is what I call recreational programming. Programming you do for sheer joy of it. Okay, it's no real. There's no other practical benefit out of it. You look at something and you find it really exciting, and you wanted to program it. Okay. Now, if you look at reasons why a lot of people program. Okay, so one is people want to get a job. Right. So when you go and I usually go to some college and then do Python workshops. People say, do I get a job if I do this course? Is Python, if I learn Python, will I get a job? Well, you may, but it's actually a lot of fun to learn, right? But I really find that aspect missing a lot of times. And also, if you look at a lot of people who are even good at programming, they try to go for the fashion. They want to do AI, they want to do ML, or they want to do data science, because that's a happening thing. Okay. Well, I mean, there's always. I'm not saying that you should not do AI or something, but the reason why you're doing something is for an external motivation a lot of times. But when it's a recreational programming, you're doing programming just for the sheer joy of it. You looked at something that really sounds exciting, and you just want to do it. There's no other motivation other than that. That's what I call recreational programming. And surprisingly, I learned programming all that way, and I don't see that many people talking about it these days. That side. Okay. So this is how I started programming. Okay. So 1997 and 96 is when I joined my BE. It's like 2 decades ago. That's my first year of engineering in 96. We had a computer center which had running, I think it's not even 386, XT machines or something, which were running DOS. And does anyone understand what that means? Does anyone know what is TP5 means? That's all, directly, but what is TP5? Has anyone heard of it before? Seen it, used it before? That's Turbo Pascal 5. Okay. So I was completely new to programming, new to computers. I went to a computer science guy and said, I want to go and do programming. How do you do? How do I get started? He said, go to computer, type CD TP5 and then TP5, you get something, write the program that you have on your paper, and then compile. If it gives errors, come back. Or if it works, run it and then come back. So what I used to do is look at a book, write down a program on a paper, and then go there and type a key in that, and then see if it works. And if it works, I was happy. If it doesn't work, I don't know what to do, so come back. That was how I really started programming. I'm sure a lot of you are much better off than me. And this is how I continued. So, like I said, I never did computer science. So, I never had any other external motivations to learn programming other than I like something, building it, and I never knew that would give me a job or not. So the only reason I did programming was the sheer joy of it. I try look at something that looks interesting. Let me see if we can do it in computer. Okay. So think of an interesting idea, implement it, then celebrate. Literally, this is the flow that I used to follow. I used to walk around, think for an idea. What should I do next? And then that will go for a week. Then I'll find something really interesting. Then I'll work on it for a week or two. And then once it's done, I'll call all my friends and say, hey, see what I've done. Okay. And fortunately, I was in a very nice college, which I never had to go to the college. So we used to probably attend like some 40% of the classes or something. I did my bachelor's from REC Bhopal. So those days, attendance was not that a big issue. I think it was very nice because you get a lot of time, whatever you want to do. There was no one really telling you should do this or you should do that. So I had a lot of free time. So really gave me a lot of time to learn programming. And I thought, let me talk about some of the interesting ideas that you may actually take it from here, take from my experience, and then actually start. If you like this approach, maybe we can follow some of those interesting ideas. Okay. So the first thing that's most exciting is when you look at computers is, can you build a game, right? So writing games is really fascinating. It's not only it's really fascinating because you actually see things happening on the screen and things keep moving and all that. Whereas you write a program to convert Fahrenheit to Celsius or some even a linked list or something, it's really, you're just looking at numbers and then it's printing something. It really don't really makes a lot of sense. But you actually build a game, that's really exciting. You can actually play it and then show it to friends. And so this is one thing that I actually did in my early days. Okay, I was really fascinated by this, and I really did it in a very crude way. And in fact, I didn't even know Python those days. I did this in Turbo C++. How many of you use Turbo C++ here? Oh, that's quite a large number. Okay, so Turbo C++ has a beautiful graphics library. All you can do is you could put pixels and then probably fill rectangles or something. And what I used to do was paint the entire screen. For each time you press a key, clear the screen, draw entire thing from scratch. Okay, and when it actually when you reach the desired position, it actually plays sound. Turbo C++ had a function called sound. You give a frequency, and then say put a delay, and then in a loop you keep on doing it. You can actually play nice music. So the game when I wrote was actually it's very crude, but it actually had this game. So one interesting thing about writing games is they teach you a lot of interesting things. One is you need to manage very complicated state. So you learn a lot about data structures. And so I never really did this to learn data structures, but it's only after I learned and actually finished my BE and then went to my master's, then I realized really I learned a lot of computer science concepts without knowing it at all. So games are really fun things to do, and you can even try. This is not too hard. If you're doing it in Python, that shouldn't take too long time. There's a nice library called Pygame. You can try it out. And this is another interesting game, I think the modern game. So 2048, how many of you know this game? Yeah, okay. So I did a Python workshop in one of the colleges in Vizag, and we built this game from scratch in a day. I'm sure you'll be able to, if you know some Python already, you should be able to do it pretty quickly. So all you have to do is figure out how to draw these things using Pygame and put in those rules in place. Okay, so the other interesting ideas are solving puzzles is really exciting. Okay, at least I used to find it very exciting. So this is one of the, I wouldn't say too easy, but low-hanging fruits. you need to put some effort to do it, but so given a chessboard, how do you place 8 queens so that they don't conflict each other? So that's a very interesting thing to try. Okay, so the other one is Sudoku. This feels a bit challenging. So I'm sure all of you know Sudoku. Sudoku is very, if you look at the rules of Sudoku, it's very easy, but playing is hard. Okay, but can you do it? Can you write a program to actually solve it? Do you think you'll be able to do it? If actually say it's actually not hard. Okay, for humans, we're not good at doing too many things. We're good at doing small number of things. We're computers that are good at large number of things. If you want to solve this in computer, you just have to do is try out all possible combinations and you'll get. I mean, you have to be slightly smarter when you're trying all possible combinations. So, for example, if you put a number, then don't try to repeat the same number again. Or there's some basic rules you can put, and then that you can try that kind of brute force, and that shouldn't be too hard to solve that. Okay, so the third interesting problem that I want to share is the game of life. How many of you heard of the game of life? Okay, so this is a game by Conway. So it's called a cellular automata. So what do is you have a grid which has cells. It's an infinite grid which has multiple cells. And each cell is either alive or dead. There are simple rules how these cells become alive or dead. So if a cell, if you look at any cell, it has 8 neighbors, like 2 on either sides, 4 on sides, left, right, top and bottom, and 4 corners. There are total 8 neighbors. And if a cell has fewer than 2 neighbors, that dies of loneliness. It feels too lonely and it dies. Okay, if it has more than 3 neighbors, it dies of overpopulation. Excuse me. Oops. Yeah, sorry. Yeah, and if it has 2 or 3 live neighbors, then it lives on for next generation. That's right. There is right living conditions. And if it's a dead cell, for exactly 3 neighbors, then it becomes alive. Okay, so these are the simple rules, and it actually makes it really exciting. Okay, let's take a scenario here. Okay, let's say that is our screen. That's our the 3 are live cells. What happens to the leftmost black cell? The black is a live cell. Okay, so what happens to that? Because it only has 1 neighbor, that would die off in the next generation. Same thing for the rightmost. The center one has exactly 2 neighbors, so that will continue to live for the next generation. And the one on the top has 3 neighbors, so that will become alive, and the bottom one will also become alive. So it will become that, and that will become black. So it's called an oscillator. Okay. So what happens if you actually have a pattern like that? That pattern becomes the horizontal pattern becomes vertical in the next generation, and then becomes horizontal in the next generation. It's really interesting to actually see the patterns taking different shapes all on its own using the simple rules. It's really fun to actually program this and then see it evolve. So there are other interesting patterns. This pattern is called a glider. So what it does is, if you look at this pattern, it becomes that and this and this, and then cycles back to this. It actually starts moving. If you start from this portion of the screen, that start moving to the end of the screen, that will keep on moving. So there are a lot of interesting patterns. Let me show you a couple of these are the, some of the patterns from Wikipedia on the Game of Life page. So if you see the first ones, they are still life. So if you get a kind of pattern that will never change, it will continue to be like that until something else comes near that and changes that's configuration. And these are oscillators that will keep on changing to the same shape. So some of them has period of 2, some of them has period of 3, and the last one, the bottommost one, has a period of 15. That will keep on changing to different shape. So metamorphism, right? So it starts with something, becomes something else, and becomes something else, and becomes something else. And if you see the ones on the right, and those are called spaceships, they keep moving. They start from one place and keep on moving to some other place. Well, so it's nothing to do with programming, but if you actually take this and then try to implement as a program, it's really a lot of fun. Okay, and you can actually create a screen full of things and then allow it to click with mouse and actually you see a nice pattern and then just keep on moving. You put a dot somewhere and kind of go on changes all the configuration. Yeah, that's really a lot of fun. So yeah, so we've seen a couple of things that I've shown are not really too hard to implement. It's just that if you really have that, if you really like that idea of what it's doing, and you can spend some time and implement those things in Python. Let me show you fractals. So fractals are an interesting concept in mathematics. So if you look at the dimensionality, if you look at a line, it's in single dimension. If you look at a shape like triangle, it's a two-dimensional. But let's take an example. Let's do an operation. If take the side of each the triangle, and then make it like an angle. So make it to the top like that, and then continue repeating it again and again. So you'll actually get a nice shape like this. Okay. So if you keep on doing it further and further, what you get is you get some kind of self-similarity. If you zoom in into any of the regions, you actually get the entire picture. So it's like you start from a very big thing and then zoom in inside. You actually go deep inside, you still find the bigger picture. So it's like if you think of the world, like even if you the same rules of nature applies even if you go to the lower level and all that. Okay. So well, for mathematically this is called a fractional dimension. It's called fractal. I'm not going to get into the details of what that is. Okay, but it really makes interesting pictures. So it's really fun to actually write a program to generate these kind of things. And this is called a Sierpinski carpet. There are a Sierpinski triangle, and this is called carpet. So can you tell me how this is generated? You take a square, and then the center of the square you divide by 3 by 3, and then start with white and then make the other one black, and then repeat the process for all the smaller ones, and then you get a nice self similarity image like this. Now if you try even more, there is this thing called Mandelbrot set and the Julia set. So there is a small simple formula to actually generate that. If you so I'm not going to get into the maths of this, but look at the picture. So if you actually zoom into that picture, you see a very nice beautiful patterns inside that, and if you zoom into that, you actually get one of this Mandelbrot set again appearing inside that. Okay, so it's really amazing thing if you just follow that link and then try implementing it in Python. It is really fun. You will spend a week time just looking at that and playing with it. And does it sound interesting? Yes? Okay. So the other thing I want to talk about is, we've seen it pictures and drawings. There are other things called little languages. I've taken this name from an article from John Bentley written in 1984, I believe, from this book. How many of you read Programming Pearls by John Bentley? So that's a wonderful book. If you have never read it, you should read it. It's a book in 1980s, I believe. It talks about a lot of programming wisdom. So one chapter of the book is called Little Languages. There's a language called Pick. So what the Pick does is, it takes a Pick program, and then you give it a Pick program that generates some output that read by a program called Trough. That's a typesetting program, and then that generates an output. What it does is, this is a program that I use to generate that picture. Saying, I'm going to eclipse ellipse that says Pick program and an arrow, and a box of Pick arrow, and then box Trough arrow, and then ellipse output. Okay, so this is written by Kernighan and some other people. Kernighan, Drecci, the C fame. Okay, so it's so easy to generate those kind of pictures. This is a language written for solving the program of drawing those kind of pictures. So it's really fun how much nice pictures you can generate just by writing simple text descriptions like this. So there are many little languages like that you can explore. It's a lot of fun. You can, for example, this picture I've generated. I don't know if you can actually see that picture, but I said I want 20 points and then connect all the 1 point each other point, and that's a nice picture that it generates. So basically, line from r cos theta to r sin theta, where I have two angles for point 1 and point B. So it just generates this nice, beautiful picture, and you can once see the idea is very simple, right? You just have to and you can actually change, instead of dot you can put a circle, or you can put text there and do all fancy things, but look at how simple you can actually do those kind of things here. Now when we talk about little languages, there are many little languages. One is one nice example. Another example is like regular expressions. For example, you want to extract numbers from a piece of text. There is a pattern, that's the regular expression pattern to actually extract the numbers out of that. You want to match HTML tags. For example, you have an HTML page, you want to extract, remove all tags and just see plain text. You match that and then remove all of that and you will actually get plain text. So regular expression is a little language for pattern matching. For example, more practical example, for example, you wanted to specify a task. This is something from my work recently. We wanted to schedule jobs, we wanted jobs to be run at periodic times. Instead of saying that some complicated frame, just let them write it as a plain text. So every day at 10 a.m. So we use regular expressions to parse that and extract whatever we need from that. So that's those are some of the little languages that you can actually learn. There are more languages. There are many little languages. Some of the other ones I would recommend are there's a language called Lex and Ack for writing parsers. They also have a very little program that you need to write to specify the grammar of the programming language that you are defining, and it actually generates a program to parse that kind of things. Now other thing that I wanted to show you is also functional programming. So Python has a lot of functional concepts, but one thing in functional programming is recursion is really amazing. Okay, so for example, look at the picture here. So this is taken from a book. If you look at the picture, the same picture is being repeated and then resized and then repeated again and then recursively put in the same place. That really looks nice, right? So so recursion lets you do all those kind of things. For example, as an example, what kind of things you can do with recursion? Let's say I have given you, I asked you to make a change of 100 using coins 50, 25, 10, 5 and 1. How many different ways you can do that? Okay, how do you find that? What if I actually give you 10 different coins instead of 5? Right, so this is, it's still too tedious to try manually. If you try using recursion, you can actually solve it very, very elegantly in like 4 or 5 lines of code. Okay, say there's option A, either do this or do that. Okay, so it's really solved very elegantly. You can do it either using the large coin or not using the large coin. Okay, so then you can split the problem into 2 smaller problems and then solve it very elegantly. So recursion really helps you solve some of these kind of problems very, very elegantly. Now what I would recommend is read this book. So if you ask me what's the best programming book I've read in my programming life, is I would say this is this book. Okay, it's called Structure and Interpretation of Computer Programs. This is a book written in a language called Scheme, but what I would say is reading that book really made me a better Python programmer. Okay, so it really doesn't matter which language that you use at work. This book is really going to make you a lot better programmer than what you are right now. Let me stop with a quote. Language that doesn't affect you the way you think about programming is not worth learning. Okay, so I think the book Structure and Interpretation of Computer Program is not just about language, but also teaches about how to understand how the language are, how things are implemented, etc., how it goes inside the machine and all that. And with that, happy hacking, and I'm open for questions. Any questions?